Thanks, Mantan. How are you, everybody? Excited to be here and talk to you about Neo4j Bloom. It's our graph visualization and exploration product in the latest arsenal of Neo4j, the graph platform. So today we have a very simple agenda. We're going to talk a little bit about the Neo4j platform, talk about an overview of Bloom as an application, and then dig into it a little bit more with the perspectives and the search capabilities that it offers, and then end with a few common Bloom patterns, like query patterns, and how you investigate, how you explore your graph data using Bloom. Patterns like that you can use for a variety of use cases. So with that, I'm going to take a couple minutes, and for those of you on the call, on the webinar here, who may be new to Neo4j, may not know all of that is there to know about us, just a couple of quick slides on that. So Neo4j is the leader in the graph database space. We have made the largest dedicated investment in graphs. We're creator of the Neo4j graph platform, but really a creator of the graph category as well. We have over 200 employees that are spread around globally. Our headquarters is in Silicon Valley in San Mateo, but we were founded in Sweden, in Malmo, and that remains one of our larger offices as well. And then we have also significant presence in London, Munich, Paris, Boston, and other places around the world. 160 million in funding. Most recently, we got an 80 million funding round, our Series E, just last month. And so we're really excited about all the promise that our investors see in this technology, in our capability to deliver, and the success that we've had so far with the 300 plus enterprise subscription customers that have greater than 1 billion in revenue. Over half of the 300 plus have over 1 billion in revenue. And so we're pretty excited about where we are, where we're going. We have a pretty vibrant ecosystem of tons of startups, a lot of community members who are even contributing and experimenting with graphs, and a huge developer presence as well, and certainly lots and lots of events that are happening. If you want to know more about Neo4j, with events such as this one, but also local events in your community, you're more than likely to find one. So a little bit about the property graph model that Neo4j has invented. So graph in general is about nodes and relationships. Some people refer to them as vertices and edges as well. But basically, with nodes and relationships and then properties, you can imagine a model like this where you have persons, a person on the left, Dan, and a person on the right, Anne, who have certain relationships. Dan's married to Anne. Dan also lives with Anne. And then other objects, such as cars, other things that they may own, other things that they like to do, other people they are related to, et cetera, you can represent them as nodes and the relationships between those nodes. But also with this property graph idea, you have properties on each of these nodes and relationships, and you can have things like labels, which you can use to describe what these nodes represent, or what those relationship types are, and then the properties that describe what those relationships represent. So the idea of a property graph and the idea of Neo4j as a native graph database is different because of the way we store data, the way we compute and query this data, even the Cypher language that we have invented that essentially represents, conceptualizes, and then helps visualize the data as a graph. And so through and through, up and down the different layers of our technology, we've optimized it for graph workloads, as opposed to other technologies that are not necessarily as much about connectedness of the data as they might be about the collection aspect of the data. So, of course, you don't just take our word for it. I mean, there's many testaments to what we're doing, as unique and as very powerful. Here's a couple quotes from the industry analysts. I'm not going to belabor them here, but just understand that we have very good recognition in the industry in terms of what we're doing. And so the database, of course, is one of the pieces. What we have provided, is a whole platform around the database, the Neo4j Graph platform. We, have strived to make it enterprise grade to enable, performance, asset transaction capabilities, schema-free agility, etc. But then also allow for you to not just store your data, but be able to perform analytics on top of that data. Enable graph algorithms that allow you to traverse the data in many different unique ways and extract insight from that information to the best of your ability. We also worked on hardening the whole platform and making it really stable over the years, worked on things like security and all the basic enterprise readiness features, all the illities, if you will, to make sure that this is truly enterprise grade. What this picture illustrates is the database is in the center, and the database is used by a lot of different kinds of users, right? You have developers and admins, you have the data integrators, you have the data analysts and the data scientists, and you have business users. And so what we're talking about today is more around discovery and visualization, but what this picture represents is that we our promise is to provide a full-fledged graph platform that is not just about a particular type of user, but all of these users, so that you maximize the advantage of your Neo4j database investment. So to talk about visualization, how is graph visualization useful? We conducted a survey from our customers a year or two ago, just to talk about visualization in general and graph visualization in specific. How they want to use it, how do they look at it. Different people have different opinions, and this is sort of a summary of what the users said they want to use graph visualization for. So they want to use it as a thinking tool to visually organize information, right? When you're talking about connectedness, it's very easy to just get on the whiteboard and draw relationships between different entities. And graph visualization takes it a step further and allows you to think of your data in much better sense. As you're developing the graph database and applications on top, the graph visualization very useful for developers as they're working with graph data. It's very useful as a communication tool to communicate to other people what you have conceptualized or what is the value that you're deriving if you're able to represent it as a visualization, and specifically a graph visualization. It's also very useful as an interactive tool for you to explore and interrogate your data in many meaningful ways. Reporting tool, analysis tool, et cetera, et cetera. So there are many different ways that people want to use visualizations, and there are many different approaches to visualizations. We're going to talk about one of those approaches, which is Neo4j Bloom. So that's basically a segue into the next set of content here. Of course, Bloom is not the only way you can visualize your graph data from Neo4j. We have a lot of partner technologies that are also developing their unique ways that they can provide value. In particular to Neo4j Bloom, the feature set that we have essentially gone towards and trying to promote Neo4j as a database that you can use for all of your connected data needs. Neo4j Bloom features the following things. So perspective, right? What is the perspective? Like that's something that's unique about Neo4j Bloom. We'll talk about that in a little bit more detail, but it's really, in summary, a business view of the graph to create different views for different perspectives for different individuals or teams that look at the graph data in many different ways, right? It might be used also for styling your data differently, or hiding personally identifiable information that certain groups should not be able to see. It's obviously a visualization tool, but it's also GPU accelerated. So we take advantage of WebGL and your graphics processor in the modern, using the modern hardware to perform to provide a high performance layout and physics mechanism for how you arrange the data, on your display. It provides direct graph interactions where you can select different parts of your graph, you can expand on it, you can dismiss it, you can find different paths in your data. It's good for inspecting certain nodes relationships in greater detail, and even allows for some editing capabilities where you can make graph changes code-free. If certain relationships need to exist where they don't, or certain properties are mistyped, or you want to create a node very quickly in your data because it's missing, those are some capabilities that Bloom provides as well. And then another unique thing that it provides is this near natural language search capability, where using graph patterns by typing in graph patterns, not necessarily Cypher query patterns, but more natural language like patterns. This thing is related to that thing. I want to understand that relationship a bit more. You can search inside of Bloom. So we'll get to this a little in more detail as we go throughout the hour here. This is what the user interface looks like. On the right hand side, of course, you can see the graph visualized or bloomed, as you can see there. On the left hand side, you can see a prompted search box, right? That's where the near natural language search query that you have is entered. Below it is the property browser and editor, where you can see the different properties and their values. And then you can also see icons and colors for the different categories of labels that exist in your data. So let's talk a little bit about graph perspective. What is the graph perspective? So like I said earlier, it's about business views of your data. Different people may want to see the graph in different ways. So the perspective allows you to manage that visibility and reduce clutter. So somebody might be responsible for creating these perspectives, and the definition of the perspective might be to selectively make certain properties visible, or certain relationships, or have category mapping to different labels, right? So that whereas the physical storage of the data might have many labels to categorize the same data, in many different ways. For a particular perspective, you may only want to see certain of those categories. So let's take an example, right? Here is a very popular data model, the Northwind relational schema. And you can see it visualized in terms of tables and columns. And so if you have category data, supplier data, customer data, it's basically a retail type of data model. And while you can definitely represent this for relational needs and aggregate needs in this way, and then use it inside of a relational database, the way graph database would visualize this is something like this. So if you have, in this case, products that are being purchased by customers using certain orders, the way you can represent it is, here's a customer. The customer has purchased, has made a purchase, and that purchase is designated by this order ID. That order can contain a lot of detail, so a lot of different line items. Here's the line item number 5. And that line item number 5 is essentially a product, that's represented over here. This product is part of a category of products, and this product is supplied by a supplier. This order was shipped via a certain shipping mechanism that you can see on this side. And then it was sold by a particular employee, and that employee reports to a store manager, let's say, and that employee also covering a particular area, a particular region for the company that belongs to a certain territory, and a certain region. So here's how you would represent that in a connected kind of fashion with nodes and relationships. And what perspectives do is essentially put different views on top of this, of this data. So if I'm the purchasing department, right, I'm a user in the purchasing department, what am I concerned about? I'm concerned about my supplies, my suppliers, and the products that we're getting from these suppliers. So what I'm interested in is this part of the graph where the supplier, the product, the product category is interesting to me. Of course, this can be much richer than what is represented here. This is just really for illustrative needs. When we look at the shipping department might be interested in the customer that is going to receive the order. What is the order? What are the different pieces or the different line items that need to be shipped? What are those products? And how am I shipping to the customer? The sales department might be interested, in much more of the order detail. So the order, who placed the order, from which store, so that they can aggregate it different, based on the different geographical characteristics and the regional characteristics, etc. The HR department may also use the same data set, but they might only be interested in relationships between an employee and the manager, and perhaps how many sales the employee is having or conducting, etc. And then you can also expose the same data set to customers by having a different perspective on top of your data. So this is the illustration of how you can have the same data set, but then apply different perspectives for visualizing it for different people. And then the other unique thing that is worth mentioning here is the near natural language search capability, which if you're searching in Google, who isn't these days, you can basically search a graph, and that's what we are striving for. And so you can search everywhere for something like Tom Hanks, right? I'm interested in movie data. I'm interested in actors. Tom Hanks is an actor I'm interested in. I can search for whatever data is linked to Tom Hanks. Or I might be interested in specifically movie information for Tom Hanks. Or I might be interested in a custom search phrase. So a custom search phrase is basically similar to what you might do with Alexa or Siri, where you would basically throw out a phrase, what is the weather today, right? And Alexa or Siri are that basically that kind of phrase is coded into their AI to basically determine the weather is the thing that somebody's interested in, where the location of this person is, which device is being used, and then combine those pieces to essentially give an answer for what is the weather today. So similarly in Bloom, you could basically create a search phrase which has parameters that you can feed to that search phrase. I'm interested in relationship between two actors, from Tom Hanks to Kevin Bacon. Tom Hanks and Kevin Bacon could be parameterized, where it could be from actor 1 to actor 2, and then that search phrase itself has some logic to how that search is conducted, what kind of query is run, and then the results. What are the results that need to be sent back so that then they can be visualized? So here's a very, very simple search phrase, which is Officer Appleby. This is the Panama Papers data set, where Appleby was an officer involved in many shell companies, and so here's the network of companies that and all the nodes actually in that data that relate to this particular officer. So you can replace Appleby with another officer, and then you'll see the search phrase essentially run with that officer in mind, and then we'll return the whole network around that particular officer, all the different entities, all of the relationships, etc. So now what you see on the screen in this particular screenshot is really a giant hairball. That's not as nice of a way to say it's a graph. It's a graph visual, but it works. It kind of signifies the complexity in this data. And while you can see some clusters of information, it may not be sufficient in telling you what you want to know. So what I thought would be interesting for the next segment of this webinar is to talk about some patterns that are very useful, that can be very useful in investigating your graph. So here's 5 common Bloom patterns that I'd like to discuss with you guys. For this purpose, I'm going to use this data set that is an Olympics data set that has information for Olympic Games from 1896 onwards. I thought it would be somewhat simplistic enough for the webinar, manageable, and pretty much everybody could relate to this kind of data. So in this particular data set, what you're seeing is there are athletes. Athletes belong to certain teams that are formed for a particular Olympic game. These teams compete in different events at the game. These teams represent a particular country. These teams then participate in a particular game that's held in a city, and then these teams may or may not win a medal, right? So when they win a medal, then that's what's represented here. So that's the data set in a nutshell. Let's get into Bloom and start visualizing, right? So here, basically you see the interface of Bloom. Here's a little sidebar. You can open up the perspective pane, and here you can see the detail around the perspective, around athletes, games, what properties should be visible, all of the different things that should be shown in this perspective. In this case, we didn't really, omit anything, so we're looking at all of the data. The legend indicates, what your data is going to visualize like. And so let's go ahead and type in city. And then you basically are returned 41 nodes, so 41 different cities that are in this data set for all the different Olympic Games that have happened, whatever is in this data. And as you see at the different zoom levels, you see more or less rich information, depending on how much you can actually visualize. Of course, at a very high zoom level, I'm sorry, very, very low zoom level, it's oops. Let me go. Give me 1 second. Get back. At a very low zoom level, you may not want to be able to visualize much, but here you can see, at a high zoom level, as I'm zooming in, you can see more detail, and then you can see that you can interact with this graph by expanding on a particular node. So that's in a nutshell how Bloom works. Very, just a very basic overview here. So let's dig into more patterns around this data. So here's the first pattern. So you want to be able to get a node and its relationships, right? That's at a minimum what you want to do from your graph. Why you want to use this pattern? You might use this pattern for exploring, around a specific starting point in your data, right? So you anchor around that starting point, and then you might want to see the relationships of that point. That point could be person, a place, a thing, whatever entities you have in your data set. You might want to have a particular relationship examined in your data. So you want to get all the information around a particular relationship. Or you may want to bring back some example data from a particular pattern. So tennis is a sport that interests me. I'm not sure if everybody on the call is interested in that, but if you know tennis, Roger Federer is a great name in tennis. Has participated in several Olympic Games as well. And so we can take a look at what Roger Federer has done, right, from this particular data set. So that's an example of, here's Roger Federer, which is a particular node, particular property, because that's the name of an athlete, right? And then Roger Federer was part of, which is a relationship, some teams, right? And the teams are nodes, and also represented them as categories inside of Bloom. So let's take a look. So we're going to go ahead and just type in Roger Federer. And as you're typing in, you can see the search, is providing some suggestions. And then you type in Roger Federer and team, and just like that, Bloom is able to understand what that query means, right? And then return the results. So Roger Federer, and then all the team relationships that he has, and then you can select the team and then expand, and then you basically start your exploration, this way, right? So you can start understanding for that particular team, for that particular game, all of the different parts of the graph that's available to you. So that's one pattern, right? You might explore by starting with a starting point, and then you start exploring relationships, and then you grow your graph, and then you find out exactly what you were interested in finding out. The next one is about understanding paths between two nodes. So here is the shortest path between two nodes. So Roger Federer is a tennis player. Serena Williams is another tennis player. I want to find out what the shortest path is. How are they connected in the smallest number of hops from one player to another. The note here is that the shortest path may not necessarily be the one you were expecting. So if you had customers in different countries, and then you're interested in the orders of those customers, going back to our Northwind example, and the products that they have bought through those orders, and you're trying to figure out the common products that they may have bought. Well, they might be related by a common country, and that might be the shortest path between them, as opposed to the products. So that's something that you just have to be careful about, and I'll explain how to get around that as well. So here in this particular example, let's play this one. So Roger Federer is obviously one of the athletes. I found him. Here's a node. And then we can find Serena Williams similarly. There's several people with the first name of Serena. We found the right one. And then now we have two of those nodes on the screen, right? We can select both of them, and then you basically get a right-click context menu where you can do many things. One of the things is to find the shortest path. And so in this case, you basically now end up with Roger Federer, Serena Williams connected through this path, where they both participated in the London 2012 Olympics. Roger Federer was representing Switzerland. Serena Williams was representing the United States. So now if I'm interested in, maybe that's not the path I was interested in, or maybe that's not what I was expecting to find. And I want to understand how Roger Federer and Serena Williams might be related otherwise, maybe along a certain type of path, right? I can use that pattern. So in this pattern, I can find out how many paths of a certain type exist between two nodes. So here, what I'm interested in is Roger Federer is part of a team, and that team participated in some games, some Olympic games. And then Serena Williams was also a part of another team, and that team participated in the same games. So that's the particular kind of path I'm interested in. So if we try to play that out, and here, go ahead and copy that in, you can see that Bloom is already, based on that string, figuring out what that path is. It shows it to you. And then when you say, yes, that's the one I want, it basically brings back the results. So here you can see that London 2012 was not the only Olympic game. Beijing 2008, Sydney 2000 were also games where they participated in the same Olympic Games, of course, through different teams. And the interesting thing is the 2004 Olympic, like what happened. So maybe that's something that you're interested in knowing is, why are they not connected that way? Maybe both of them didn't participate in the games, one of them did, or none of them did, and so on. The next kind of pattern is exploring depth. This is something that you may want to, use for, let's say, a supply chain use case or a dependency mapper kind of use case. Let's say you're mapping dependencies between your network, systems. You can also do it for like a bill of materials type of use case where, one thing is a part inside of another thing is a part of, inside another thing, et cetera, et cetera. So you can figure out how many, like, how many levels deep does that go, and what kind of a hierarchy is built in my data set. So using this particular example of the Olympic game data set, we can look at athletes related to teams that have other athletes that are related to other teams related to other athletes, et cetera, et cetera. So just basically see the linkage between different athletes, how through which teams are they linked together. People might use this kind of a data set. I'm sorry, this kind of a pattern also for exploring fraud rings or doing connectedness of different bad actors, etc. In law enforcement, for example. So here's that pattern. You can see Bloom visualizes that as the different labels, the different categories that you're connecting together. And there you go. And you find, in this case, different clusters. So here's another one cluster, another one, and then a pretty large one over here. We can start looking into these clusters. And as you zoom in, it shows you again more detail. So here you have Daniel, who was part of the Poland team for canoeing. Also was Elvira, and Elvira was also playing for Switzerland, maybe for another game. And then Pierre, who was also participating with France. And so you can see that different athletes are coming through and participating in the Olympic Games through different countries even. Here's a much bigger cluster, and I'm not trying to need to drag it. So here you can see a much more richer connections between like the different fencing teams in France. And then finally, this cluster where we can, as we zoom in, we can visualize the Belgium equestrian athletes and how they formed different teams. And then some of them participated in rowing as well. So that's pretty interesting from this data. And then the final pattern that I want to talk about today is the more than one type of. So when I want to find out about elements that we have more than one instance of. So a very simple one is, how many games has a city hosted? So we can basically do a pattern like this where you can find out city games, very simply, and then you can extend this out, to more of a recursive, alliteration kind of a way, right? Where you essentially have the athlete in the center, and you're trying to figure out, how many gold medals has this athlete won as part of not just one team, but maybe as part of separate teams. How many different teams has this athlete participated on and then contributed to the gold medal? So athlete is in the center, and you basically have athlete part of this team. Team won the medal type of gold. So what you should note here is that the medal is the node, right? And the medal has a type property, and the type property has a value of gold. And so what we're putting in this pattern is a very complex set of query parameters, which is this node with this property, with this value, with this relationship to another node, with a relationship to another node, et cetera, et cetera. And once we go ahead and try it, you'll see that how Bloom visualizes it. So we'll start with the first example of games for the city, and you can see that the cities with different games that were held. And then we're going to put in this other pattern that we saw, and then Bloom recognizes this pattern as well. And then it is pretty interesting in this data set that there have been many instances, 1,000 total nodes have returned here, where you can see where the athlete has essentially participated in different teams and then won the gold medal. So this particular Swedish team has essentially won multiple gold medals. And they probably were from different games. And so you can continue your analysis by focusing just on this group of nodes, dismiss all the other nodes, and then expand that network to see which games, in which cities, and then whatever other data that you may want to add to this data set to explore that in more detail. So I hope that some of these examples were, a good illustration of what you might want to conduct on your graph database. It is not obviously just restricted to sports analysis. This is just an illustration of the kinds of pattern matching that you can apply, and it applies to customer 360 use cases, applies to fraud detection use cases, anti-money laundering, when you're trying to figure out cyber threats, if you want to figure out social media relationships, network relationships, IT security use cases, and so on and so on. So supply chain, tariff, impacts, right? That's pretty noteworthy in this day and age, right? And so with Neo4j Bloom, right, everyone can have a very appropriate business view of the graph, as we saw. You have graph beginners or experts, like can explore the graph with just near natural language search capability. You don't need to know, Cypher queries or any other kind of query language. You basically type in your patterns. You do need to understand a little bit about the graph data model. And as we looked at the initial data model for Northwind as well as for this Olympic data set. So you do need to understand some of that. And also it's important that the graph data model is well defined, because then the domain users can relate to the model just like they have it in their head. They can start typing in, and that's very important for search, right? The person is thinking about a particular entity. This is how they think about it. This is how they know it relates to other entities. So if the graph data model mimics what the user is thinking about, it makes it very intuitive for that user to put in the query that they then want the answer to.